Hi everybody, I hope you had a great week, or if it's the end of the day, I hope you had a great day today, or both. Today's video is going to be another lesson planning video, and today we're going to be doing a couple things. We're going to be doing a constructivist lesson, as always, but then we're also going to be using a really great piece of technology that is absolutely free. The name of that technology is Desmos. So this is Desmos. You can get to it just by typing in Desmos, DESMOS.com. You can make yourself a free account with any email you choose to use. And it comes with ready-made activities that are completely able to be customized. So you can customize them to your heart's content. You can make your own. It's really great because it comes with a lot of different types of tools like graphing calculators, regular calculators. Let's see, here's the graphing calculator where you can just put in different types of equations or points in here and have the students engage with them. And you also have the ability to keep an eye on what your students are doing by going into sort of the back end, the teacher planning area. So I really like it. It's a way, especially if we have to move towards online learning, it's a way that you can have the students either work independently with peers, you can have conversations, you can share different components of the lesson or different answers. It's really just limited by your imagination. So today, to keep things simple, we're going to do the following. We're going to be doing a lesson on finding distances on the coordinate plane, and you can participate by actually going into the link, into the Desmos link, and trying out some of these activities on your own. So I'm going to kind of show you what you can do with it and how this can actually become a really nice, interactive, constructivist activity on how we can calculate distances between 2 points on a coordinate plane, and then also how to use the points of the coordinate plane to do the calculation arithmetically. So let's do that now. The standards that I will address in this lesson are from 5th grade, and it's the 5th grade geometry standard, the first one, so 5G1, and it says use a pair of perpendicular number lines called axes to define a coordinate system with the intersection of the lines, the origin, arranged to coincide with the 0 on each line and a given point in the plane located by using an ordered pair of numbers called its coordinates. Understand that the first number indicates how far to travel from the origin in the direction of one axis, that's the x-axis obviously, and the second number indicates how far to travel in the direction on the second axis, which is the y-axis, with the convention that the names of the two axes and the coordinates correspond. So it's saying that the x-axis and the x-coordinate correspond, and the y-axis and the y-coordinate correspond. In addition, I will be working with the standards for mathematical practices, SMP 1, make sense of problems and persevere in solving them, SMP 2, reason abstractly and quantitatively, SMP 4, model with mathematics, SMP 5, use appropriate tools strategically, and SMP 8, look for and express regularity in repeated reasoning. After selecting the standards, the next step is to write specific learning objectives to operationalize behaviors that are aligned with the construct. I have written 3 specific learning objectives for this lesson. My first specific learning objective is given graph paper, students will calculate distances on a coordinate plane by counting the spaces between 2 points. The second is, given 2 coordinate pairs, students will calculate distances on a coordinate plane by using the values. So they will be using either both of the x values or both of the y values to calculate the distance between the 2 coordinate pairs. And finally, given a scenario, students will explain what a value of 2 coordinates Either both the X values or both the Y value pairs represent by using appropriate math vocabulary. For assessments, I will be looking at the Word Web Graphic Organizer. I will be using the Common Core State standards for mathematical practices 1, 2, 4, 5, and 8 that I listed in the previous slide. And I'm also going to be using all the results in the explanations and the calculations that the students did on the Desmos activity. The name of the Desmos activity that I modified for today's lesson is called Collect the Coconuts. I did very slight modifications. Most of the slides that you will see were already there and ready to go. It made it very easy to select the right activity for today. The beginning of each lesson, we want to activate prior knowledge. So we want to give the students a chance to kind of situate themselves in the lesson. And what I would do for this particular lesson, and this is just an idea, there are many things you can do, but what I thought to do for this particular example is just on the board, write the word graphs, or you can write it on one of those big pieces of Post-it papers and just write the word graphs, and then tell the students, you know what, boys and girls, I'm going to give you a piece of paper and I want you to draw a circle in the center, and I want you to write the word graphs in the center. And we're going to take a few minutes. I'm going to set the timer and I'm going to give you a few minutes to brainstorm about words that come to mind when you think about the word graph. So I'm going to go ahead and set the timer now and give you a minute. Now, you don't have to worry about spelling this correctly. I just want you to put as much as you can on the paper. And then let the children do that. Give them a chance to just start throwing all their ideas down. Okay? After 3 to 5 minutes, I would go back and then I would ask the children to start sharing their ideas while putting it on the wall for them. At that time, I would also tell them, boys and girls, I'm going to ask you what things that you wrote down in your brainstorm, and I'm going to go ahead and write them up here. After we get a lot of your ideas up here, I'm going to give you a few minutes to go back so that you can change the spelling as needed. And as we're doing this, I really want you to think about how, as we continue our lesson, you know where these words are located so that we can use them in our conversation. So that's how I would start prior knowledge, giving them time to start to situate themselves, start to think about vocabulary. But the nice thing about this is it scaffolds. So for our children that are just English language emergent, it gives them a little bit of me time to be able to code switch. It gives you time even to maybe support them by helping them with some cognates. As I said, there's lots of websites that will give you cognates for every single lesson, depending on what language you're interested in and what your topics are. So this kind of gives you a little bit of time to situate them, and then you just have a nice little conversation about how these words are meaningful to graphs, and they could just be anything. Also, giving the children time to change anything that they need to on their individual word walls. What we're doing really is creating a word wall for their use. You're creating one for the class, and they are also creating one for their own use later. So we want to make sure that they're correct, and the children are also expected to use the vocabulary well, but also the spelling as well too. Okay, so like I said, after the students have brainstormed their ideas, create a class word web and discuss how the terms are used. Tell the students that the word web or the word wall will be used throughout the lesson for students to practice using their math vocabulary. So you've set the expectation that we're going to be talking about stuff, and they are expected to use the words appropriately. And you'll be adding to the words too. Once we've tapped prior knowledge, now we're ready to go into the concrete stage of the exploration. In order to do this, what I would do is I would give all the students a piece of paper with the actual coordinate grid in front of them. If you're able to get a larger piece of paper that has larger squares, the better. So it'll be nicer to have sort of larger squares instead of itty-bitty squares, because that can make it more difficult. And I would tell them that I want them to fill out the values on the X and Y axis. And then they should have a partner check their sheet to make sure that the labels on the axes are correctly labeled and that they have written the numbers correctly. So if this is the coordinate grid, I would want them to have this center portion as the origin labeled as 0, and then positive numbers going to the right, negative numbers going to the left, positive numbers going up, and negative numbers going down. Now this, of course, would be something that you've already taught in the class. That's what kind of makes looking at lessons in grades, anything besides kindergarten or preschool, a little bit more difficult to situate within the year, because we want to make sure that we're very clear about what the students have been exposed to. So by the time we've started this lesson, they would have been exposed to understanding how to read coordinate pairs and how those numbers are determined. So looking at the attributes of the two axes and how to name a point. So I would allow the students to use this hard copy as their concrete manipulative, along with either a marker or a pencil, whatever it is. This will also be another piece of scaffolding if students have any problems working with the computer activity. After the students have created their coordinate plane and they have labeled it correctly, then I would ask the students to go ahead and log into their Desmos account and type in the class code. So if you want to do this now, that'd be great. You can do it a couple different ways. You can either click on this link, which as always is in the Google slide, in the description box below, and you can also find this in Blackboard. Or if you already have a student account, you can just type in this 6-digit code. The nice thing about Desmos is you have an option of creating your own personal account as a student, or just using it anonymously. If you want to use the Desmos account anonymously, that's great, but it won't save your work so that you can go back to it later. If you make yourself your own student Desmos account, then you have access to all the activities and your answers and your changes and everything for as long as you have the account. That's another plus of having it there. Students can always go back and use that as a reference. So the students can go in and look at the activity. I'm going to go ahead and go into the student-facing screens of this Desmos activity so you have an idea of what I would project on the smartboard or whatever I might be using to help the students. In the first slide, I just wanted to give the students an opportunity to respond. I made the slide myself so that you could see kind of what could be done in a more personal level. So in this slide, I've asked the students how they are, and they can click to however they feel, and then click next. Okay, so this brings us to the very first really exploratory activity, and it says, visit Island B to collect the coconuts. Enter the distance between the islands in the table. Note the unit of measure for this activity is miles. So here we have Island A, and here we have Island B. And I would ask the students, what do you think? How could I figure out how many miles apart these two islands are? I would probably expect the students to say, well, we could just count up the spaces. If every space is a mile, then we can just count up the spaces. And some of them might just count them up as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And some of them might say, well, here's 5 and here's 7. So that whole distance is going to be 12 if we add 5 plus 7. Right? You just kind of discuss what it is. Now you can also just have the students see if they can determine this on their own, and they can just type in their answer here, and it'll say like collect the coconuts. And here it has this little boat that comes over that if they do it correctly, it'll actually tell them you found the coconuts, right? And if I would have maybe put something that was less, let's just say I put 5. The little boat would have stopped sooner. Or if I put something that was more, the little boat would have passed the second island, Island B. So it gives them an opportunity to kind of explore. Now again, you might think to yourself, well, how hard is this? Remember, you're not a 5th grader, right? Something like this may seem extreme to a 5th grader. So let's go to the next one. This time, notice what's missing. There are no grids. So the student will have to make a decision on how they're going to calculate this. Some students will have to go to their coordinate plane, the concrete representation that I gave them, that's the piece of paper, and then go and count. Some of them might say, well, here is 12 and here is 2, and I know that because here is a 12 and here is a 2, but that's a negative 12, right? So it's starting this conversation, and the students can decide what they want to put as their answer and put it in here. So I'm just going to put 14 here. And it will tell them if they got the answer right or not. It says you found the coconuts, and then here it says, since this graph does not have a grid, how were you able to calculate the distance between the 2 islands? And I would ask the students to go ahead and write this, and to make sure that as they're writing this, that they look at their own personal word web or word wall, or the one that we created as a class, so that they can get used to using that vocabulary. Okay. Now, if the students aren't figuring out that they have to look at the 2 x-axes, if that hasn't come up yet, just let it sit for a while. Maybe you'll be able to guide them to that later. So I'm just going to type in, I counted on my grid paper. Next. Now let's look at this one. This one has the islands where one is further north than the other. Maybe a student is unsure on how to do this. And notice that this one has -2 and -11. So the students have to make sure that they're interpreting these coordinates correctly, right? It's not 0, +2, it's 0, -2. Now, I'm pointing this out to you because we're adults, but if I were the teacher, I would say, let's think about what you can do here. Some students might say 13 is the correct answer. Some students will notice that these are both negative and they're both going to be on the y-axis below the origin, and so this difference is going to just be 9. Some students may think it's -9. In 5th grade, you're not really talking about absolute value yet, but that's certainly something that it's related to in the future, is looking for a distance is never negative. You cannot have a negative distance. So one thing that the students can do is they can actually use this thing called the sketching tool. So here they're at -2, they can actually start to count. -3, -4, -5, -6, -7, -8, -9, -10, -11. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a difference of 9. So use the sketching tools if it helps you use your thinking. And they can write. I used the sketching tool to draw lines for the spaces. I counted the lines after I drew them, and there were 9 lines. Okay. And it'll say, by looking at the coordinate pairs, do the x-coordinates or the y-coordinates have the needed information to find the distance between the islands? And have the students write something out. Some of them might say it's the x-coordinates, right? They're not understanding which ones are the x and the y. Some of them will say it's the y-coordinates. We don't know. But this will give you information about where the students are actually making the connections. Okay? Same here. This time, instead of it being on 0, this island is in the 1st quadrant and this island is in the 4th quadrant. So the students still have to figure out, okay, what am I doing? I'm looking for a vertical distance. And what you're wanting the students to do, to construct in their mind, if I want to calculate a distance vertically, I need to look at my y-coordinate. If I want to look at a distance horizontally, I want to look at the x-coordinate. So here we're going from A to B. A student could say, well, it's from the difference between 3 and 3 is 0. And you can have conversation. Well, does that look like a 0 distance? What does it mean to have a 0 distance? What happens if you use the y coordinates, right? 1, and actually draw it off. So there's 10, and then there's 5 more. So this is how this is becoming a constructivist lesson. You're not telling the student, okay, we're going to calculate a vertical distance. So if we're going to calculate a vertical distance, we're going to look at the y coordinates, and we're going to take the absolute value of those y coordinates. Okay? You're not looking for them to do that. You're looking for them to make sense of this. This one is interesting. This one says, Ashan thinks the distance between island A and island B is 7 miles. Is he correct? If the students are struggling with this, have them do it on their piece of paper. If they need more than one piece of paper, you might want to consider putting it inside a sleeve protector or a page protector and having them work on it with a dry erase marker, right? So these are all situations where they're determining on their own how to calculate these distances. This one, they might be like, well, here's 10 and here's 2, so this distance is 7, but they're not one above each other, are they? This is kind of off to the side, so we don't really know what that might be. Here's another really great one. Which island is closest to island A? Is it island B or is it island C? So in both of these instances, what are you doing? You're guiding the students to interpreting each one of these coordinate pairs and taking these values to do a little bit of arithmetic, or alternatively, using their piece of paper to be able to count the distances using their piece of paper. This one's a challenge where they have to measure distances from island A to B, from B to C, from C to D, and from D to E. So they're having to switch back and forth between having to use the x coordinates to the y coordinates to the x coordinates to the y coordinates. Really, really nice. Same thing here. They're having to switch back and forth, right? Now, is it wrong for a student to use the grid every single time? It is absolutely not wrong. If that's how they're making sense of this, then they should continue to use that grid until they're able to let go of it. Now, can you guide the students to trying to help them uncover the similarities and the patterns? You should, absolutely. And having them try to engage in different ways is fine too. But ultimately, if the only way that the student can actually perform the task is by counting, then you let them count. Okay, this is one activity. They don't necessarily have to go from the concrete to the representational to the abstract in one lesson. Again, this is going from the concrete, which is the grid paper, the graph paper, to possibly using like the sketch tool to count up the spaces in between in a way that makes sense to them, to finally using the symbols and the arithmetic to find the distances. This is a really great one too. Which of these sets of points could represent the coordinates of the islands on this diagram? What's this looking to say? This is looking to see, well, these are directly one above the other. So does that mean that they have the same x coordinate or the same y coordinate? Right? And this would be a way to assess that. Finally, the last slide that I have made for them is this thing called the muddiest point. The muddiest point is a really quick monitoring technique that can be used for formative assessment. And the students just take a few moments to write down what part was the most confusing of the lesson so that you have information about how to go back and either reteach, form groups, differentiate, change pace, whatever it is. Okay, so this activity right here is a technological lesson where the concrete is just a piece of graph paper. Students are working towards interpreting coordinate pairs to find distances between the two, and they are left to their own self-regulation to determine if they want to do this using the graph paper or if they want to do this arithmetically. So here are some guiding questions that I would use during the lesson. What strategies can you use to find the distance between the two islands when only the coordinate pairs are given? You can use the graph paper. You can add the distances from the origin or from each other. You're always looking for a positive value. Not that, I don't think students in 5th grade have even started to add negative numbers, so we're just really talking about distances. What is the relationship between the coordinates and the orientation for the distance you calculated? If you want to find a vertical distance, you're going to be using the y values, and horizontal distances, you're going to be using the x values. Now, these are the big ideas, right? They're really what you're aiming for students to understand eventually. If it doesn't happen in one lesson, that's fine. Students aren't always going to get things in one lesson. Sometimes they do, sometimes they don't. It's just what it is. So as the students work on the slides, I would just start to look for examples and non-examples of using correct values to find distances. And you can actually post the work anonymously. I don't have enough work on this particular activity for you to be able to see that, but if I wanted to, I could go here into collecting the coconuts, right? And this is what the students had been using. And I can look to see where they are. So these little dots right here are where the students are in their work. This is what the student sees. This is what the teacher sees, so that it can show who is feeling great, who's feeling okay, etc. This is a summary of where the students are. Be able to see where the students are working and how I can pull ideas out of here. I can pull ideas or snapshots out of here for me to post. Now notice right here where it says Taurus course, that's me, but if I want to anonymize, it gives the students the name of a famous mathematician. And if I want to say, okay, so this student did this work and I want to share it with the class, I can take a picture of it and it brings it up here in the snapshots so that I can bring the snapshots and compare them up here and just post all this stuff on my smartboard. So I could just pull things on here. I don't have any student work at this point because nobody's worked on it since the time that I have created this. Slide 7 is great because it discusses why Ashan's ideas are correct or incorrect using math terminology. So this is a really great time to put new words on the word web. Slide 8 is really great to begin to summarize the big ideas. That when you're working with the vertical distances and trying to calculate vertical distances, you're looking at what the y value is telling you, the two y values. And horizontal distances are calculating using the x values. And again, you want to add new words to the word web. You can have their students in the representation phase after the lesson is done. I would give them more graph paper and give them colored pencils or crayons or whatever it is that they like to draw with, and have them do their own colorful island map on their own. That's very similar, where there were several islands that they had to go to and to write the coordinate pairs and then find the distances. Or if you have time, have them swap with a neighbor and see if they can do that too. So these are all really great activities that do what? They give the kids time to reflect because they have to draw, they have to color, they have to create their own keys, right? They're doing all these things in a very low anxiety setting, and they're still producing documents, evidence that you can use in order to assess them and either align your lessons better for differentiation, for pacing, whatever it is. And then by the end of class, I would say they should return to fill out slides 11 and 12 by the end of class period, so that you're getting a very brief assessment, almost like an exit slip, and also getting input as to what points they feel they need help with. That works with self-regulation. As a summary, what I would do is write a point, and I would actually keep the point in quadrant 1 on the board and ask the student several questions. So, for example, let's just say that I decided to use the point 7, 10. So 7, 10 is going to be over 7, up 10. So it's going to be up here. We can ask them questions like, if we wanted to figure out what coordinate pair is exactly 5 units to the left of this point, what would we do? And hopefully, some of them will be able to say, well, I would subtract 5 from the x value. So if my point is 7, 10, I would subtract 5 from 7. If I asked, what can we do to figure out what coordinate pair is exactly 5 units to the right, we're hoping that they'll say something like, well, then I would add 5 to the 7. If I wanted to ask the question, how can we figure out what coordinate pair is exactly 5 units above this point, then we're hoping that they would say, well, I would add 5 to the 10 because 10 is in the y coordinate spot. It's the y value. And then finally, ask them, if I wanted to know what coordinate pair is exactly 5 units below this, what number would I go to? What would be that coordinate pair? Then hopefully they're going to subtract 5 from the 10. So they know how they can negotiate these changes in space, right? Just by looking at the point. Now, are all kids going to be able to do that? Absolutely not. Not after the first lesson. What's important is that you're having these conversations so the children that are starting to understand are able to have that social dialogue. The students that are just starting to piece things together are seeing how their peers are approaching the question. And some kids, maybe they're still using the paper, and that's perfectly okay. For this plan, you will find the Desmos link is going to stay in there indefinitely. So anybody that sees this lesson plan in the future will be able to go into this link, click on it, and be able to access the activity. And I will be adding the supporting resources into a Google file in a drive so that you can have access to things like a piece of graph paper and the written lesson plan, possible questions, things like that. Final points. Constructivist lessons are important. But first of all, you have to be aligned with the mission and the vision of your school. If the expectations at your school is to teach a different way, then you should finish that expectation. But there's always a way to blend in good practices with existing resources. Find some way to bring in that constructivist component. You should not be doing all your lessons, I do, we do, you do. That's not good pedagogy. That's direct instruction. And I think that at this point in the semester and this point in the course, you should have a very clear idea as to why that approach has not been successful. And what we need to do is change that dynamic. So while I do, we do, you do might be the norm for your school and what would be expected, that does not necessarily mean that these type of activities are taboo. There's place for this if you're smart about how to integrate them into your existing curriculum. So that's pretty much all I've got to talk about when it comes to this lesson planning 101, finding distances between two coordinate points. I hope you guys have a great rest of your day and come visit again as I add more lesson planning 101 lessons to this channel. Have a great rest of your day. Bye!